One of the challenges of managing a network is servicing devices in many different locations. For example, you might have a main office in one location and a branch office in another location connected with a WAN link. What do you do if something goes wrong, or a server in the branch office if it's located hundreds of miles away? Even if your network only has a single geographic location, you'll probably run into situations where a problem appears in the middle of the night or while you're away on vacation. Without remote management, you'd have to drive to the office to troubleshoot the problem. Remote management lets you manage devices without being physically present at the console. A typical device like a server or a router has a console connected. For example, a server might have a keyboard and a monitor. Use the keyboard to manage the device by typing in commands and making changes. Some devices like routers don't have keyboards or monitors. Instead, they have a console port that connects to a laptop or some other device through a serial connection. The laptop runs console management software that's used for device management. In both of these cases, you must physically be at the device to manage it. With remote management, however, you replace the console with a network connection. A network connection to the device is configured, and then another device is connected through the network, allowing you to manage things as if you were physically present. The network connection sends and receives information from the device. This is preferable to flying into a remote office or coming in late at night to fix problems. There are several types of remote management solutions that you should be familiar with. The first is called terminal emulation. Terminal emulation does just what its name implies. It emulates the physical console terminal of the device remotely or through a network connection. Terminal emulation software runs on a remote device, such as a PC or laptop, and connects to the device, allowing you to issue commands and view information. For many years, administrators used the Telnet protocol for terminal emulation. However, Telnet does not use encryption. Because of this, all information is transferred as clear text between the device and the remote terminal emulation software, including administrative usernames and passwords used to authenticate to the device. A malicious person sniffing network communications could easily capture sensitive information. For this reason, Telnet is rarely used today, even for terminal emulation sessions on the same local network segment. The risk of compromise is too great. Instead, most administrators use the Secure Shell, SSH, protocol for terminal emulation. SSH uses very strong encryption, which makes it difficult to view information being transferred between devices. With SSH, you use an SSH utility to open a terminal emulation session with the device remotely over the network. The SSH utility displays a text-based window where you type commands that are sent to the device. Responses from the remote device are also displayed in this window. Even devices that use a graphical user interface typically support terminal emulation using SSH. A second type of remote management solution is remote desktop software. With this solution, you see the entire graphical desktop of the device, not just a text-based window. A remote desktop connection has three components. The first is the target. The target is a network device, server, or workstation that you want to manage remotely. It has to run remote desktop server software that allows it to establish connections. If the target has a host-based firewall running, then you need to open the appropriate ports to allow remote desktop sessions to be established. The second component is the remote desktop client. This is a network device, such as a workstation, laptop, or tablet, that runs the remote desktop client software. The client device has a network connection to the remote desktop target system. The third required component is a remote desktop protocol that specifies how information is passed between the target and the client. You use remote desktop software on the client to establish a connection with the target. The remote desktop protocol transfers the desktop of the target device to the client and displays it there. The display includes all open windows, start menus, and anything else that was present on the target device. On the client, you use the keyboard and the mouse to send commands to the target using the remote desktop protocol. The target receives these actions and uses its processor and memory to execute those commands, such as closing a window, entering text in a file, or launching an application. The actions executed on the target usually result in a change to the graphical information displayed on the desktop. As the screen is redrawn, the remote desktop protocol sends the changes back to the client system, where the updated information is displayed. The remote desktop protocol is also responsible for optimizing the data that's passed between the target and the client. This is particularly useful in situations where the remote connection has been established through a slow internet connection. The protocol optimizes data transmission so that only the necessary information is sent. For example, if the remote desktop screen is updated with new information, the protocol will preserve graphical elements that haven't changed and transfer only the elements that have been changed. This dramatically increases the session speed. In addition, the protocol may employ compression algorithms to further reduce the amount of data that's sent between the target and the client. Many remote desktop protocols are also capable of resource redirection. For example, you could create a print job on the remote target and have it redirected to a printer connected to the client system, which could be miles away from the target. You can also redirect audio to the client from the target. Some remote desktop protocols also allow storage devices on the client to be accessed from the target. This means you could create a file on the target in a remote desktop session and save it to the client's hard disk. You can also use remote desktop solutions for remote assistance. Users who are experiencing problems with their system can request that you connect remotely into their computer to view the symptoms or even take control of their desktop to troubleshoot problems. There are several different protocols that are commonly used for remote desktop connections. Virtual Network Computing, VNC, was one of the first remote desktop solutions. It's an open source solution that was originally designed for Unix. VNC software is currently available for Linux, Windows, and Mac OS. The Independent Computing Architecture, ICA, by Citrix is another option. It was initially developed only for Windows, but now there are versions for other operating systems as well. For Windows, the Remote Desktop Protocol, RDP, from Microsoft is widely used. Versions for Mac OS and Linux are also available. When selecting a remote desktop solution, you should ask several key questions. Will it run on the target host's operating system? Does it provide client software that will run on the client system's operating system? Can I use a web browser to connect to the target from the client? This will help you determine which solution to use. Now let's talk about remote access policies. If you're the only person remotely accessing network resources, then this won't be a problem. But chances are other employees will want remote access too, and they'll want to use unregulated personal devices, personal networks, and public networks. You need a way to regulate all of this access, and the solution is to implement remote policies. Your company should have a remote access policy document that every employee is familiar with. This document should specify acceptable ways to dial into a network and access resources. For example, it would be a good idea to prohibit using Telnet since it's unsecure. Make sure to specify standards that remote access devices must achieve, too, like having the latest patches and receiving regular virus scans. Lastly, include a statement that requires employees to agree to follow the remote access policies so they're held accountable if they don't. That's it for this lesson. We looked at remote management solutions that allow you to access and manage a remote device, a router, switch, server, or workstation, as if you were physically present. This is accomplished by using a network connection. Terminal emulation provides text-based remote access and is commonly used to manage routers, switches, and Linux servers. Remote desktop protocols are used to provide access to systems that use a graphical interface, such as Windows servers and workstations. And we talked about implementing remote access policies to keep your network resources safe.